Hello, everyone. We're looking into how to find inverses. We're not going to worry so much right now about restricted domains, so we'll just stick to the idea of how to find inverses. There's two ways to find an inverse. One is graphically, and one is algebraically. The graphical method requires you to take the graph and reflect it over the line y equals x. So this is the line y equals x. If I were to fold it on this line, if I fold the graph on this line, that graph would be flipped. Its image would appear over here. How to find it is I'm going to find, how about this, the vertex right here. The vertex, remember reading it from vertex form, is -5, 3. Its image, when you reflect it over this line, is going to become 3, -5. That's what happens when you reflect it. Now I'll draw it and you'll be like, yeah, I can see that. So 1, 2, 3, 1, 2, 3, 4, 5. And then the parabola is going to open to the side. Can you start to see if you were to fold it over? And in class we'll actually do this. So if you're watching this and you haven't had a chance to actually do it, come to class and ask about it, and we can actually fold these things, and you can see it actually works. Okay. This vertex, or this corner point, you can get from the equation. It's going to be 5, -3. To get where this point's going to go in the reflection, and this is going to be true for any point that's on this graph, if you find any coordinate and then switch the x and y, so we'll have -3, 5 is going to be on the new graph, or on its reflection. 1, 2, 3, 1, 2, 3, 4, 5. I know it's hard to see. The graph didn't copy well. This piece is going to continue in the same direction. It's going to be down here. And this one is going to continue off in this direction. Okay? So you're hoping that you can see, if you folded it over that line, this is what it would become. So this is the inverse of this graph. This is the inverse of that one. Or you could say they're inverses of each other. That is the inverse of this one. Okay. This graph, if that coordinate that it starts at is 0, 1, 2, 3, 4, so it's at 0, 4, 4, 0 is going to be on the new graph. It's going to be on the inverse. So 1, 2, 3, 4. And this graph is going to go right up through there. If a graph crosses the line y equals x, that point will be on the reflection. Okay? So this black one would fold right onto the blue one, or the blue would fold right onto the black one, whichever way you want to say it. And I mentioned before, if any point is on that line, it's going to stay there. And this one's a little harder to see. If you wanted to pick the actual coordinates and plot the actual coordinates, you could. But in the interest of time, I'm just going to sketch out approximately what the thing's going to look like. It's going to look approximately like this when you do the reflection. Okay? Yeah, I believe that's right. Perhaps I'm a little bit off. Or does it curve the other way? Should I have... No, I think it's right. Should have curved here. The point being, how you can do it is take these individual points and reflect it across. Because I'm trying to rush a little bit, because it's really hard to do this virtually, that I need to be able to have this thing and be able to fold it in hand. That's the intent of it. Like I said, you guys can always take these points and actually do the reflection. So if we go 1, 2, 3, 4, 5, 6, that's going to be, that's -6. 1, 2, 3, 4, 5, 6, and a little bit more, because that was 6 and a little bit more. So this is going to be -6, 1. So that will be 1, -6. And then this is going to be -5, 2. So that'll be 2, -5. And then that's going to be -4, 3. So 3, -4. And then it's going to curve out this way. So I think I was right. Okay. All right. Yeah, that's the way I curved it that way before. Okay, so there we go. Now, that's the graphic way of doing it. The algebraic way of doing it is, in days of old, like 2 months ago, you guys used to think of this as y is equal to x plus 5 squared plus 3. So f of x is really just your y value. And up here, what I was doing was taking the coordinate, say for example, -4, 3, and I switched the x and y to get 3, -4. You physically switch the x and y to get the inverse. So that's what you do. Pretend you got the y equals instead of f of x. Switch your x and y. Whoops, made a mistake already. Y plus 5 squared plus 3. Now you guys have to solve for y. And all year long, you guys have been working with PEMDAS. Parentheses exponents, parentheses exponents multiplied by add subtract. You're working up PEMDAS to undo stuff. So you have to undo this adding and subtracting first. So you subtract the 3. There's no multiplying and dividing. The multiplying or dividing would occur out here or underneath. Okay? There's none of that to get rid of. So we go after the exponent. I want to get rid of the square. So I'm going to put a square root on the page that wasn't there before. So that's going to create a plus and a minus. So I have plus and minus square root x minus 3 equals y plus 5. The parentheses are gone. You return back to the bottom and start the process over again. So I'm going to subtract the 5, subtract the 5, -5 plus or minus the square root of x minus 3 is equal to your y value. Now, notice there wasn't a y in the original problem. Okay? So, to finish it, what we have to do is write it without the y value. You don't replace it with an f of x. You replace it with a notation that says it's its inverse. And it looks similar to f of x, except for my really lame looking f there. And the additional piece of information that you're going to put is a -1 right there. That says it's the inverse of the original function. Now I know it's annoying. If you guys had this to the -1, that says take the reciprocal. If you guys had x to the -1 over 3, that would become 1 over 3x. Okay? A -1 means take the reciprocal of whatever that is sitting on. This, when it's written between the name of the function and the variable, it does not mean reciprocal. It means inverse. So yeah, it's unfortunate that they use a similar notation to something you already know, but that's beside the point. It means something different when it's written here. Okay? It's not reciprocal. So your final answer would be f inverse of x is equal to -5 plus or minus the square root of x minus 3, and that would be your final answer. Okay? So I'll erase this and do the next one. Oops, a little far. Okay, so pretend you got a y. Switch your x and y. PEMDAS, subtract the 4. Okay, then, whoops, square root's still there. I have to get rid of the square root, so I'm going to square both sides. There wasn't a y in the problem, so I go to write it as its inverse. F inverse of x is equal to x minus 4 squared. Okay. Now there is a piece of information I'm leaving out, but I want you guys to be able to get comfortable finding the inverses before I start talking to you that there's actually a problem with this one. It's not going to hinder how you guys actually go and find the inverse. It's actually an interpretation. It's what I scribbled out up here at the top. Restricting the domain. For now, we're not going to worry about restricting the domain. We actually have to do it. We haven't rehearsed very much on what domain is, let alone how you would go about restricting it. So, just in the interest of being forthright and open that, hey, there's actually more to this. Okay? But for now, I'm fine that you guys, if you can get this far, I'll be tickled. Okay? Okay, perhaps not tickled, but I'll be whelmed. No, I'm just making fun of the word. I will be very happy if you guys can get this far. So there you go. Yikes, where's the stop button? There it is.